Operating a forklift might seem straightforward, but it's a task that requires precision, understanding, and respect for the principles of stability. Whether you're in a warehouse, on a construction site, or in any other environment where heavy lifting is necessary, understanding the fundamental principles of forklift stability is important for both safety and efficiency. Most forklift accidents occur from forklift tip-over or falling loads, often resulting in injuries or even fatalities. But these risks can be avoided if we understand the dynamics at play when we're operating a forklift. In this training, we'll explore the mechanics of stability using familiar concepts and metaphors to provide a comprehensive view of how balance, weight distribution, and dynamic forces interact. From a simple seesaw analogy to more complex three-dimensional models like the stability pyramid, we'll look into the core concepts that every forklift operator should understand. By breaking down these principles into relatable terms, this training will equip you with the insights that you need to operate a forklift safely and effectively. Let's get started. When it comes to understanding the dynamics of operating a forklift, you can start by imagining a simple seesaw on a playground. It's a familiar and effective way to introduce the essential terms and concepts related to stability. First, the fulcrum is the pivot point around which the seesaw balances. It's the point that supports the entire system, allowing it to tilt back and forth. The center of gravity is the average location of all the weight in the system. For example, with no one on the seesaw, the center of gravity remains perfectly balanced at the fulcrum. But if a child sits on one end of the seesaw, the center of gravity shifts toward the child, and the seesaw tilts in the same direction. If a child of identical weight sits on the other side, the center of gravity returns to the fulcrum, and the seesaw is balanced. However, if an adult sits on one side of the seesaw, the center of gravity will shift more toward the heavier adult, and the seesaw tilts accordingly. Up to this point, most of this should seem pretty familiar to you. But stability is about more than just the weight on either side of a fulcrum. Another factor is how far that object is from the fulcrum. If the adult moves closer to the fulcrum, then the effect of their weight on the side of the seesaw is reduced, and the center of gravity would then shift accordingly. This principle can even allow a small child to lift a heavier adult by sitting further from the fulcrum than the adult. Similar to a seesaw, a forklift also operates on the principles of balance and stability. With the front wheels of the forklift acting as the fulcrum and the forklift having its own initial weight, we can see how various load weights and distances can shift the center of gravity and lead to imbalance and a tip over. With a load weight of 0, the center of gravity remains squarely toward the forklift, and there's no risk of tip over. When the load weight exceeds the capacity of the forklift, then the center of gravity can shift beyond the front wheels, leading to the risk of a tip over. The same can happen if the load is placed too far from the front wheels. Now that we understand the basic principles of stability, we can take things a step further by introducing the concept of the stability triangle. In the world of forklift operation, understanding the concept of the stability triangle is crucial. Unlike the simple seesaw, a forklift stability depends on a three-point suspension system. Imagine a triangle with its vertices at the two front wheels and the center back steer axle. This forms the stability triangle. When the forklift center of gravity remains within this triangle, the system is stable. When the center of gravity exits the boundaries of the stability triangle, the forklift becomes unstable, leading to potential tip overs, falling loads, or even loss of control. For example, with a load weight of 0, the center of gravity remains firmly centered in the stability triangle. As the weight of the load increases, the center of gravity shifts forward. Remember, distance also affects the center of gravity, so a heavier load positioned close to the forklift can lead to instability if positioned further away. The concept is similar for lateral stability. When a load is extra wide or unevenly distributed, this can shift the center of gravity to the sides of the stability triangle and lead to a lateral tip over. While these principles apply mainly to standard forklift dynamics, it's worth noting that specialized configurations like reach trucks, side loaders, and telescopic handler forklifts, they might require slightly different applications of the same physical principles. For example, a lot of forklifts include counterweights at the back to help maintain the center of gravity within the stability triangle. But some forklifts broaden the stability triangle using extended legs called outriggers. Understanding the role of counterweights and alternative mechanisms can be helpful in grasping forklift stability, depending on the type of forklift that you're using. In any case, to maintain stability and avoid a tip over, it's important to remember the following key takeaways. Never exceed the stated weight capacity of the forklift. This limit is usually found on the forklift's data plate or nameplate. Minimize the distance from the forklift to the load center. Load as close as you can to the forklift and place the heaviest part toward the mast. Travel with the mast tilted back, never forward, to keep the load close and stable. Center the weight of the load between the forks and distribute loads evenly to avoid any lateral tip overs. Pick up off-centered loads with extra caution. And stop operating a forklift if the back wheels begin to lift off the ground, since this is an indication that the forklift is overloaded. While the concept of the stability triangle explains stability on a two-dimensional level, forklift stability also involves a third dimension, transforming the concept into what we call the stability pyramid. This three-dimensional concept provides a more nuanced understanding of forklift stability and accounts for its height. Imagine the center of gravity as a ball hanging from the top of the pyramid. Depending on the height of the load, the shape of the pyramid then changes. When the load is kept low, the stability pyramid is short and sturdy, with the center of gravity securely positioned within the structure. As the height of the load increases, the stability pyramid becomes tall and narrow, making it easier for the center of gravity to exit the narrowing limits and lead to a tip over. Essentially, the higher the load is lifted, the more precarious the system becomes. To prevent the risk of a tip over, be sure to keep the load as low to the ground as possible, especially when traveling. While the concepts of the stability triangle and stability pyramid offer vital insights into the balance of a forklift, it's important to recognize that these models primarily consider static conditions. In the real world, a forklift doesn't just stand still. It accelerates, brakes, turns, lifts, and tilts. This leads us to the concept of dynamic stability. When operating a forklift, any sudden movement causes the center of gravity to shift. For example, sudden acceleration or braking can move the center of gravity to the front or back of the stability pyramid, while rapid turning can also shift it to the sides, increasing the risk of a tip over. Smooth, controlled movements help to maintain a balanced center of gravity and minimize this risk. Operating on an incline or decline also introduces complexity. The center of gravity can shift due to the slope itself and any movement on that slope, like turning on a grade or a ramp. Be mindful of slopes and gradients. Approach inclines and declines straight on, never at an angle, and avoid turning on any grades or ramps. Loose, damaged, or unstable loads can also impact the center of gravity. For example, if a load tilts or shifts during transport, it might move the center of gravity unexpectedly, leading to instability. Make sure all loads are properly secured, and exercise extra caution with loads that are loose, damaged, or inherently unstable. This vigilance helps to maintain stability and reduce the risk of accidents. Situational awareness is also important because it helps you to avoid sudden corrections, which can destabilize the forklift and lead to safety hazards like tip overs, fallen loads, or collisions. Pay attention to your load's dimensions in order to avoid collisions with overhead structures, objects, and people. Keep a safe distance from walls and other obstacles to minimize sudden movements that could destabilize the forklift. And exercise caution around blind spots like corners and doorways, making sure to slow down and use your horn to let others know that you're there. In our exploration of forklift stability, we've covered concepts and real-world applications. By comparing a forklift's balance to a seesaw, we introduced essential terms like fulcrum and center of gravity, demonstrating how weight and distance impact stability. We extended our understanding to the three-point suspension system in a forklift, illustrating how keeping the center of gravity within the stability triangle is vital for avoiding tip overs and loss of control. We expanded the concept to 3 dimensions, illustrating how height affects stability, with the key takeaway to keep loads low to the ground, especially when traveling. Lastly, we emphasize the real-world complexities of acceleration, slopes, and unstable loads, stressing the importance of smooth movement, caution on gradients, and proper load securing. Operating a forklift safely requires a nuanced understanding of stability, careful consideration of load positioning, and smooth control of movements. So, whether you're a seasoned operator or new to forklifts, understanding and adhering to these principles helps us to maintain balance and prevent accidents, contributing to a safer work environment for ourselves and everyone around us.